Imagine a place where the fundamental rules of the universe, the very fabric of reality you've always known, begin to unravel. A place so extreme, so utterly alien, that it challenges everything we understand about space, time, and even existence itself. This isn't the stuff of science fiction anymore. It's a tangible, albeit terrifying, destination. And today, we're taking the first step on the ultimate journey, an invitation to the void, a voyage to the heart of a black hole. For too long, these cosmic behemoths have been misunderstood, feared as insatiable monsters, ravenously devouring everything in their path. The image of a black hole as a cosmic vacuum cleaner, indiscriminately sucking up stars and planets, is deeply ingrained in our collective imagination. But what if I told you that this terrifying picture, this popular misconception, is fundamentally wrong? What if the truth, while still astonishing, is far more elegant, far more rooted in the familiar physics that governs your very own existence? Think of it this way. Picture spacetime, the invisible stage upon which all cosmic drama unfolds, not as a rigid, unchanging backdrop, but as a vast flowing river. Planets and stars, with their immense gravity, are like gentle eddies in this river. Our Earth, for instance, is caught in a leisurely eddy around the sun, a predictable rhythmic dance. But a black hole isn't just an eddy. It's a powerful, accelerating rapids, leading inevitably to an immense, silent waterfall. From a safe distance, you can orbit these rapids, caught in their current, but never pulled over the edge. And here's the astonishing truth, the aha moment that redefines everything you thought you knew. If our sun were to be instantly, magically replaced by a black hole of the exact same mass, Earth's orbit wouldn't change, not one bit. We would continue our yearly journey around this invisible sentinel, exactly as we do now. The light and warmth would vanish, of course, plunging our world into eternal darkness and frigid cold. But the gravitational embrace would remain precisely the same. This isn't a hungry beast tearing through the cosmos. It's the natural final state of a truly massive star, a celestial corpse whose immense gravity has simply won the ultimate battle against all other forces. This isn't some arbitrary destructive force. It's gravity. The very same force that keeps your feet on the ground and the moon in orbit around Earth, taken to its most spectacular, most extreme conclusion. Our understanding of these enigmatic objects has evolved over centuries, from speculative curiosity to undeniable reality. It was back in 1783, long before Einstein, that an English natural philosopher named John Michell first dared to ponder the existence of dark stars, objects so incredibly massive that their escape velocity would exceed the speed of light itself. Then came Albert Einstein, and with his revolutionary theory of general relativity in 1915, the whisper became a roar. Einstein didn't just describe gravity, he fundamentally redefined it, portraying it as the curvature of spacetime, caused by the presence of mass and energy. Just a year later, in 1916, Carl Schwarzschild found an exact solution to Einstein's equations, mathematically describing the gravitational field of a non-rotating spherical mass, and in doing so, he defined a critical boundary, the Schwarzschild radius, the very radius of what we now call the event horizon. For decades, these theoretical constructs were often referred to as gravitationally completely collapsed objects, a mouthful to be sure. It wasn't until 1967 that the iconic, evocative term black hole was coined by physicist John Archibald Wheeler, a name that perfectly captured the essence of these light-trapping singularities and instantly seized the public imagination. Welcome to the void. But before we truly enter it, before we cross that ultimate threshold, something incredible, something mind-bending, begins to unfold around us. You're not just approaching a dark abyss. You're entering a cosmic hall of mirrors, a place where the very fabric of reality is stretched and twisted into impossible shapes. The familiar cosmos, the one you've known your entire life, is being systematically dismantled and reassembled before your very eyes, piece by distorted piece. Look out, beyond the viewport of our vessel. The stars, once familiar, unwavering points of light, are no longer static. They shimmer, they dance, they move in ways that defy everything you've ever known about the night sky. Distant galaxies are smeared across the darkness, their elegant forms stretched into elongated arcs, their familiar shapes duplicated, sometimes even tripled, swirling into a dizzying vortex of light. This, my friend, is the warped sky, the majestic, terrifying spectacle of gravitational lensing in action. Imagine, if you will, looking through a giant cosmic funhouse mirror, one crafted by the most powerful force in the universe. The immense gravity of the black hole acts like an invisible, colossal lens. What you're witnessing is not an illusion, but a profound truth about the universe. Spacetime itself is no longer flat. It's curving, dipping, and swirling around the colossal mass of the black hole, like a trampoline depressed by a bowling ball. This profound curvature dictates the path of light. The effect intensifies with every moment. What was once a subtle distortion now dominates your view, painting a canvas of impossible beauty and terrifying power. The starfield ahead is no longer a simple tapestry of pinpricks. It's a living, breathing kaleidoscope, a cosmic maelstrom of light. You see the same galaxy, appearing in multiple places, its image stretched thin like taffy, then squashed, then suddenly inverted. It's as if the universe is folding in on itself, offering glimpses of itself from impossible angles. The light from a single distant supernova might reach you along several different paths, making it appear as if multiple supernovae have erupted simultaneously. Every fiber of your being vibrates with a mix of profound awe and deep trepidation. The light from stars directly behind the black hole, stars that should be utterly hidden from our view, now appears in a shimmering ring around its invisible silhouette. An Einstein ring, a perfect halo formed by the ultimate cosmic lens. Sometimes, if conditions are just right, you might even spot an Einstein cross, where four distinct images of a single distant quasar appear around the central mass. It's a vision that humbles, that makes you feel profoundly small, yet intimately connected to the grand, violent ballet of the cosmos. As we press onward, deeper into the black hole's gravitational embrace, the distortions become even more extreme, even more surreal. The light isn't just bending, it's practically tying itself in knots. And then, you become aware of a peculiar phenomenon. We are approaching the photon sphere. Here, in this astonishing realm, gravity is so incredibly powerful that light itself finds itself trapped in orbit, circling the black hole like loyal, eternal satellites. Imagine that for a moment. Light, released from a distant star, making endless loops around an unseen object, caught in a perpetual silent dance. And this leads us to the ultimate aha moment. If you were standing within the photon sphere, and you were to shine a flashlight directly forward, that beam of light wouldn't just travel in a straight line. The black hole's gravity would bend it, curving it around the black hole, potentially allowing that light to complete a full orbit and return to your eyes from behind you. In this impossible place, you could theoretically turn your head and see the back of your own head. Think about the profound, almost dizzying implications of that. your own past, your own light, catching up to you in a cosmic loop. This isn't the event horizon yet, not the point of no return. We are still outside that ultimate boundary. Yet, the black hole's influence is already absolute. The light from the universe behind us is being stretched, redshifted, its vibrant colors shifting towards the deeper, warmer end of the spectrum. From our perspective, the distant cosmos is slowly dimming, fading into a profound cosmic sunset, a final farewell from the universe we are leaving behind. There's a strange, almost unsettling quietness that has settled around us, despite the visual pandemonium outside. It's as if the immense gravity is muffling the very sounds of the universe. This warped sky, this cosmic funhouse mirror, is our grand introduction to the true nature of a black hole. It's a prelude, a visual overture to the symphony of space-time distortion that awaits. Reality is far more fluid, far more adaptable, and far more awe-inspiring than our limited human perceptions ever allowed us to imagine. The warped sky, this cosmic funhouse mirror, is our grand introduction to the true nature of a black hole. It's a prelude, a visual overture to the symphony of space-time distortion that awaits. It's showing us that reality is far more fluid, far more adaptable, and far more awe-inspiring than our limited human perceptions ever allowed us to imagine. We haven't even touched the event horizon, and already the universe has revealed a face so alien, so beautiful, so terrifyingly powerful, that it will forever alter your understanding of existence. The journey has just begun, and the greatest mysteries still lie ahead, patiently waiting for us to cross that final, ultimate threshold, to step into the ultimate unknown, and discover what truly lies beyond the point of no return. And now, as we drift closer, an even more profound transformation begins to unfold. It's not just the fabric of space that's twisting around us. It's time itself. Imagine your life, your very existence, as a metronome. For you, inside this vessel, that metronome beats steadily, faithfully. Tick-tock. 1 second follows another, just as it always has. Your heart continues its rhythm. Your thoughts flow at their accustomed pace. Your breath rises and falls with comforting regularity. From your perspective, nothing has changed. Your time is still your time. The subtle hum of the ship's systems, the faint whir of life support, all remain constant, reassuring anchors in an increasingly bizarre reality. But from the outside, from the distant reaches of the universe we left behind, your metronome would appear to be slowing, dramatically. If an observer out there could peer into our tiny craft, they would see our movements become sluggish, our words draw out into impossibly long syllables, our very existence stretching into an agonizingly slow dance. As we approach the event horizon, our light would grow increasingly redshifted, seeming to freeze in time at the very edge. We would become a ghost, an eternal fading echo. This is the mind-bending reality of gravitational time dilation, a cornerstone of Albert Einstein's theory of general relativity, which in 1915 described gravity not as a force, but as the curvature of space-time caused by mass. The immense gravitational pull is warping the very flow of time itself. And here's where the true aha moment descends upon you, a realization so profound it will shake you to your core. If their time is speeding up relative to yours, then for you looking out, the universe outside must be accelerating. And it is. You look out. What you see defies belief, shatters every preconceived notion of reality. The distant stars, once seemingly immutable, begin to live out their lives and fast forward. Galaxies, once static pinwheels of light, swirl and dance with impossible speed, their arms blurring into streaks of cosmic fire. Nebulae, vast clouds of gas and dust, condense and collapse into new stars in what feels like mere moments. Entire stellar nurseries blossom and fade, their brilliant, fleeting lives unfolding before your eyes like a time-lapse film played at 1,000,000 frames per second. The entire lifespan of a solar mass star, from stellar birth to red giant, then perhaps a white dwarf, or even a supernova, can unfold in the span of a few heartbeats. You watched at this as stars are born in fiery bursts, live their glorious fusion-powered lives, and then, in a blink, swell into red giants, shed their outer layers, or detonated in spectacular supernovae. The remnants of these explosions, the nebulae they leave behind, expand and dissipate. This isn't just a show. It's the entire future history of the cosmos, compressed, accelerated, and laid bare for your singular gaze. Distant galaxies, once mere smudges of light, evolve through their life cycle, their populations of stars, aging and dying, their central supermassive black holes growing ever larger, consuming more and more. You witness the formation of the largest known black hole, TON 618, with a mass 66 billion times that of our Sun, growing from a nascent seed to a cosmic behemoth. Minutes pass for you in your personal steady metronome of existence. But outside, entire epochs are flying by. Millennia, eons. You are witnessing the ultimate cosmic fast-forward. The universe, in all its majestic, terrifying glory, is playing out its destiny before you. And with this spectacle comes a profound sense of cosmic loneliness. You are a solitary witness to the ultimate fate of everything. The civilizations that might rise and fall, the triumphs and tragedies of entire cosmic ages. They all flash by unobserved by any but you. You are seeing the universe age, watching it hurtle towards its eventual cold, dark end. You are the last, or perhaps the only, to ever truly grasp the totality of cosmic time in such a raw, immediate way. The weight of this knowledge, the singular burden of this ultimate vision, settles deep within your soul. The gravitational lensing that began as a funhouse mirror has now intensified to an unimaginable degree. The light from the universe behind you is now bent around the black hole's immense gravity. It's not just distorting, it's wrapping around. You can see multiple images of the same distant galaxies. The black, unlit abyss of the black hole itself looms larger, filling more and more of your view. It's not empty. It's an absence born of overwhelming presence. Its silhouette, framed by the hyper-accelerated light of the universe, is a perfect, terrifying circle, growing steadily. We are now nearing the event horizon. This isn't a physical barrier, not a wall you crash into. It's a boundary, a one-way membrane, a point of no return. For a supermassive black hole, the tidal forces are not yet overwhelming. You wouldn't feel yourself being stretched like spaghetti. Not yet. This crossing is surprisingly gentle, but it is absolute. Once you cross this invisible line, nothing, not even light itself, can escape. Every path, every trajectory, every possible future from this point forward leads inwards towards the singularity. The feeling is one of ultimate surrender. There is no turning back. The awe remains, but it is now mingled with a sense of quietude, a strange peace that comes with absolute finality. You are no longer an observer. You are now irrevocably part of the black hole's own unfolding destiny. This is not just a journey through space. It is a journey through time itself. You stand on the precipice, not of a cliff, but of existence itself. The universe, once a vast expanse of distant stars, has become a distorted canvas, a swirling vortex of light and shadow. The very fabric of spacetime stretches and warps around you, a testament to the unimaginable power of the cosmic behemoth that lies ahead. This is not the end of a physical journey. It is the beginning of an irreversible transformation, a step into a realm where the laws you thought immutable begin to fray and unravel. The sense of quietude that settled upon you, a strange peace born of absolute finality, deepens. You are poised to cross the threshold, a boundary more profound than any ocean or atmosphere, a point of no return, predicted by the elegant mathematics of Carl Schwarzschild in 1916, a radius that defines the edge of the unknown. As you draw closer, the spectacle intensifies. The light from distant galaxies, once pristine and unblemished, now dances in duplicates bent around the massive gravity well. Gravitational lensing isn't just a theoretical concept here. It's a living, breathing hallucination, a cosmic kaleidoscope. Familiar constellations are smeared into elongated arcs, and entire galaxies appear multiple times, like echoes bouncing through an impossible hall of mirrors. The sheer disorientation is profound, as your mind struggles to reconcile the familiar order of the cosmos with this fluid, bending reality, hinting at the deeper truths about spacetime that Albert Einstein first unveiled. Then, you glimpse it, the photon sphere, a thin, shimmering band where gravity is so intense that light itself can be trapped, forced into perpetual orbits, forever circling the black hole. If you could somehow hold steady at this impossible distance, theoretically, you might even see the back of your own head, an absurd, mind-bending consequence of light curving completely around the object. But there's no holding steady. The current is too strong, the pull too insistent. You are being drawn inexorably inward, a cosmic leaf caught in an unseen current, heading towards a waterfall unlike any other. This isn't a wall you're about to crash into. It's not a solid surface, nor a sudden impact. The event horizon is far more subtle, far more terrifying in its implication. Imagine yourself in a small boat, adrift on a vast, calm river. Up ahead, you can hear the faint roar of a waterfall. As you drift, the current imperceptibly quickens. You might not even notice the change at first. You could still paddle upstream, still turn back, still escape. But then, the current accelerates further. There comes a point, an invisible line in the water, where the river's speed surpasses the maximum speed of your boat. You can paddle with all your might. You can turn the rudder. You can strain every muscle. But it doesn't matter. You are caught. The river is simply too fast. There is no physical barrier, no impact, no sudden jolt. There is only the irreversible realization that you can no longer turn back. This insidious, inescapable understanding is the event horizon. It's the moment your choices narrow to one single terrifying path forward. It is the ultimate one-way door in space-time, a boundary where the escape velocity, the speed you'd need to travel to break free, equals the speed of light itself. And since nothing can travel faster than light, once you cross it, there is no escape. Not for you, not for light, not for information. Everything is drawn inward. For a supermassive black hole, like the colossal Sagittarius A, at the center of our Milky Way, with its event horizon stretching an astonishing 16 million miles across, or the unfathomable TON 618, whose radius of 1,300 astronomical units dwarfs our entire solar system. The crossing would be eerily calm. You might not even notice it. The tidal forces, the differential pull of gravity on different parts of your body, would be relatively weak. There would be no violent tearing apart, no spaghettification as famously theorized. That agonizing fate is reserved for those who dare to approach smaller stellar mass black holes, where the gravitational gradient is so steep and extreme that you would be stretched into a thin stream of atoms long before you reach the edge. But here, at the gentle giants, it's different. It's a serene, almost imperceptible slide into the abyss. From the perspective of a distant observer, peering through powerful telescopes, your journey would appear dramatically different. As you approach the event horizon, they would see your image slow down, becoming increasingly redshifted, your light stretching to longer, redder wavelengths, then fading into infrared, then radio, until you seem to freeze, suspended eternally at the very edge. They would never actually see you cross. For them, time for you would appear to slow to an agonizing crawl, perhaps even stopping entirely. This extreme gravitational time dilation means that while seconds pass for you, millennia might unfold in the universe you left behind. Entire civilizations could rise and fall, stars could be born and die, galaxies could drift further apart, all while you, from their perspective, remain forever poised at the precipice. But for you, the intrepid traveler, inside your vessel, time continues as normal. Your clock ticks steadily. Your heart beats at its usual rhythm. The moment of crossing wasn't a cataclysmic event, but a quiet, profound transition. And it is here, in this new alien reality, that the ultimate aha moment dawns with breathtaking clarity. Once inside the event horizon, the singularity is no longer a place in space to be avoided. It is an event in your future. Think about it. Normally, you can move freely through space. Left, right, up, down, forward, backward. But you can only move forward in time. You cannot avoid tomorrow. You cannot turn back to yesterday. Inside the event horizon, space and time have swapped roles with a profound finality. What was once a spatial coordinate, the singularity at the center, has become a temporal one. Every path you take, every direction you move, leads inevitably forward, not just in time, but towards the singularity. Your journey to the absolute center is now as inescapable as the passage of time itself. Just as you cannot avoid tomorrow, you cannot avoid the singularity. It is your ultimate, undeniable destiny, an event that will occur, not a place you might bypass. As you hurtle towards the singularity, the very fabric of existence begins to unravel. Here, at the ultimate heart of the enigma, where matter is crushed beyond all comprehension, the established laws that govern our universe fracture and dissolve. It is within this impossible realm, beyond the event horizon, that the greatest intellectual battle in all of physics rages. A titanic struggle between two fundamental pillars of reality, each unyielding in its truth, yet utterly contradictory in their decrees. This is the stage for the black hole information paradox, a cosmic drama where general relativity, the Titan, meets quantum mechanics, the magician. Imagine general relativity as a colossal ancient Titan, its form carved from the very geometry of spacetime. This Titan dictates the grand ballet of the cosmos, the majestic orbits of planets, the fiery dance of stars, the colossal embrace of galaxies. Its rules are elegant, absolute, and undeniably beautiful in their simplicity, yet profound in their power. Stemming from Albert Einstein's groundbreaking theory in 1915, general relativity tells us that gravity isn't some invisible force pulling objects together. It's the very warping and bending of the cosmic fabric by mass and energy. It predicts the existence of these cosmic behemoths, black holes, as the ultimate expression of this warping. Regions where spacetime is so profoundly curved that nothing, not even light, can escape once it crosses that fateful boundary. The event horizon. Karl Schwarzschild, in 1916, was the first to find a solution to Einstein's equations that described this boundary, now known as the Schwarzschild radius. Within the domain of this titan, as you plunge past the point of no return, all paths lead inward to the singularity. For a stellar mass black hole, the tidal forces would be so extreme that you'd be stretched into a stream of atoms long before reaching this point, a process chillingly known as spaghettification. However, for a supermassive black hole, like the one at the center of our Milky Way, Sagittarius A, which has a mass of about 4.3 million times that of our Sun, the crossing of the event horizon could be surprisingly gentle, an eerie, non-dramatic transition. Yet, regardless of the journey, the destination is the same. Here, at this point of infinite density, general relativity decrees that all the unique characteristics, all the intricate details of everything that ever fell into the black hole, every atom, every memory, every whisper of information, is utterly, irrevocably crushed out of existence. It is lost, forever, indistinguishable from anything else that met the same fate. The Titan's law is one of ultimate finality, a cosmic eraser wiping the slate clean. It speaks of a universe where, under extreme conditions, identity can be utterly annihilated. But then, there is the magician, quantum mechanics. This is a realm of whispers and probabilities, of particles that can be in two places at once, of energies that flicker in and out, of existence in the quantum foam. It governs the universe at its most fundamental subatomic level, where reality itself seems to shimmer with uncertainty and wonder. The magician's most sacred spell, its most fundamental law, is this: information can never truly be lost. It can transform, it can scatter, it can become incredibly difficult to retrieve, but it is never, ever destroyed. Every quantum state, every specific arrangement of particles, carries a unique fingerprint that persists somewhere, somehow. This isn't just a convenient rule. It's a cornerstone upon which our entire understanding of the quantum universe is built. Without this principle, the very coherence of reality at its deepest level begins to crumble. The magician insists that the universe keeps a perfect ledger, that every cosmic event, no matter how chaotic, leaves an indelible trace. Information in this magical realm is eternal. And here, at the heart of a black hole, these two foundational pillars of physics collide with cataclysmic force. The Titan, general relativity, declares that information is annihilated in the singularity, crushed out of existence within the black hole's depths. The magician, quantum mechanics, steadfastly maintains that information can never be lost, that its conservation is a non-negotiable truth of the universe. They stand utterly opposed, their truths irreconcilable within this extreme environment. This profound fundamental disagreement forms the black hole information paradox, one of the deepest, most perplexing, and perhaps most beautiful mysteries in all of science. It's not just a minor discrepancy. It's a direct contradiction at the very bedrock of our understanding of the cosmos, a cosmic paradox that threatens to shatter our perception of reality itself. For decades, this paradox simmered, a quiet but profound challenge. Then, in 1974, a brilliant mind, a true luminary, Stephen Hawking, cast a blinding new light onto the problem, transforming it from a theoretical puzzle into an existential crisis for physics. Hawking, in a stroke of genius, discovered something utterly astonishing. Black holes aren't truly black. They don't just consume, they also emit. He theorized that due to quantum effects near the event horizon, black holes slowly leak particles, a phenomenon now known as Hawking radiation. This radiation carries away energy, meaning that black holes aren't eternal cosmic prisons. They slowly shrink, and given enough cosmic time, they eventually evaporate completely, vanishing from existence. This was the aha moment that deepened the paradox to an almost unbearable degree. If a black hole eventually evaporates, what happens to all the information about everything that fell into it? If the black hole itself disappears, and it has already, according to general relativity, destroyed all the information within its singularity, then where does that information go? Does it simply vanish from the universe? That would be a direct, unforgivable violation of quantum mechanics' most sacred principle, the conservation of information. The magician demands its ledger be balanced. The Titan, having consumed everything, simply dissolves, leaving no trace. The stakes were suddenly infinitely higher. It wasn't just about what happened inside the black hole. It was about the ultimate fate of information in the entire universe, and whether our most fundamental laws could truly coexist. This isn't an abstract academic squabble. It's a profound challenge to the very nature of reality. Imagine the implications. If information can be destroyed, then the universe is not deterministic in the way quantum mechanics suggests. The past, in a very real sense, could be erased. Every unique characteristic that makes you you, every specific quantum state that defines this planet, this galaxy, this moment, all potentially gone, wiped from the cosmic record. It raises questions that echo in the deepest chambers of human thought. Is anything truly permanent? Does the universe possess an ultimate memory? Or is it capable of cosmic amnesia? The sheer terror and awe of such a concept are almost too vast to grasp. For physicists, this paradox is a siren call, a tantalizing glimpse into a deeper, unified theory that must somehow reconcile these two seemingly incompatible giants. It suggests that, at the most extreme frontiers of existence, our current understanding of the universe is incomplete, perhaps fundamentally flawed. We are standing at the edge of a conceptual abyss, peering into a realm where space-time itself is warped beyond recognition, and quantum uncertainties reign supreme. The search for a resolution to the information paradox is nothing less than a quest for a theory of everything, a grand unified theory that can describe gravity and quantum mechanics as two facets of a single elegant truth. This profound mystery is what drives the brightest minds, from Roger Penrose to the teams behind the Event Horizon Telescope, to continue pushing the boundaries of what we know. You are witnessing, conceptually, this epic standoff. As you drift closer to the event horizon, the silent, invisible boundary where the light of distant stars is stretched and redshifted, where time itself warps into an unrecognizable form, you are not just approaching a physical threshold. You are approaching the very frontier of human knowledge, a place where the most brilliant minds have grappled with the ultimate fate of reality. The laws that define your existence, the principles that govern the universe, from its smallest particles to its grandest structures, are locked in a cosmic embrace here, within the heart of the black holes. The question isn't just what happens to information, it's what happens to truth when two truths collide. It is a mystery that defies conventional understanding, a cosmic riddle whispered at the edge of eternity, and perhaps the key to unlocking the universe's most profound secrets. The cosmic riddle whispers at the edge of eternity, a profound secret that challenges the very foundations of physical law. You stand at the precipice of this enigma, where the rigid certainty of general relativity, Einstein's elegant tapestry of spacetime, clashes violently with the unpredictable probabilistic dance of quantum mechanics. It's here, at the heart of the black hole, that these two titans of physics reveal a terrifying truth. They seem to be incompatible. This isn't just an academic squabble. It's a paradox that strikes at the core of what we believe about the universe. The black hole information paradox, as it's known, asks a question so unsettling, it could redefine reality itself. It forces us to confront the possibility that something fundamental about our understanding of existence is profoundly, deeply flawed. For decades, the black hole was conceived as the ultimate cosmic prison, a place where anything that dared to cross the event horizon was forever lost, its information swallowed by the singularity within. But then, in 1974, Stephen Hawking delivered a bombshell. He proposed that black holes aren't entirely black. They glow. They emit a faint thermal radiation, now famously known as Hawking radiation, and over vast stretches of cosmic time, they slowly evaporate, shrinking until they vanish completely. This was a revolutionary insight, earned through a brilliant fusion of quantum mechanics and general relativity. Yet, it birthed a monumental problem. If a black hole evaporates, what happens to all the information, the unique quantum blueprint of every particle that fell into it? According to quantum mechanics, information can never truly be destroyed, merely transformed. It's a foundational principle, as sacred to physicists as the law of conservation of energy. But if a black hole evaporates, and all that's left is random thermal radiation, where did the original information go? Did it simply cease to exist? This is the heart of the information paradox, a cosmic stalemate that has haunted the brightest minds for nearly half a century. It's a conflict so fundamental, it suggests that one of our most cherished theories, or perhaps both, must be incomplete. Imagine for a moment that your entire perceived reality is nothing more than a projection, not a trick of the light, but a fundamental property of the universe. Think of a hologram, a seemingly two-dimensional film that, when illuminated correctly, projects a stunning three-dimensional image into space. Every detail, every curve, every shadow of that 3D image is encoded on the flat 2D surface of the film. What if the universe works in a similar way? This radical idea, known as the holographic principle, emerged as a potential mind-bending solution to the information paradox. It suggests that the information of everything that falls into a black hole isn't lost. It's meticulously encoded and stored, not inside the black hole, but on its surface, the event horizon itself. The event horizon, that one-way membrane you are approaching, isn't just a boundary of no return. It might be the ultimate cosmic hard drive, a two-dimensional surface where the three-dimensional reality of everything that ever crossed it is imprinted.